Hello guys, can you all hear me?
Good morning,
Everyone,
Richa.
morning,
Yes.
good afternoon, good evening. Thank you for
Hello.
confirmation. I'm sharing the screen. Okay, confirm me guys if you all can see the screen.
Yes. I see your screen.
Okay, perfect. Tell me, what did we learn last class? Remember,
Clustering.
clustering means what things in clustering,
K means
especially.
cluster.
K means clustering, right?
Yeah,
We saw
K means
type of
clustering the K value,
type of
defining the K value and the elbow rule and printing the categories post applying the model.
Yes, perfect. So guys, now from today onwards, we're gonna start with the new topic, which is deep learning processes. Deep learning is something you will be again using machine learning and all one more time to implement deep learning models. It is just an extended version. So tell me, anyone who knows what is deep learning, especially at your knowledge, how would you define deep learning?
Would it be when models begin to train themselves?
Good. Anything else?
It's a subset of machine learning.
Very good.
We use
So
neural networks.
yes. So in machine learning, basically we use models, but in deep learning processes, we use neural networks. Actually, this is the Venn diagram. You have AI. Inside AI, we have machine learning. And then under machine learning, we have deep learning processes. The problem with machine learning, it can only handle a limited amount of data. Means afterward, the performance of machine learning model is not that optimal, which is why researchers have derived a new field, which is deep learning. So if I just explain this as a definition format, so deep learning is a subfield and from a field of machine learning and AI that is inspired by the structure of human brain. The way human brain used to think. Okay. In the similar way, deep learning model used to perform the activity. And as I wrote this Venn diagram, this is your AI. We have machine learning, and under machine learning, we have deep learning process. Now we'll discuss why deep learning is very popular. Why everybody wants to learn deep learning. Do you have any comment on this? Why deep learning is so popular, guys?
I don't know.
Handle big datas.
Explain a bit more.
Maybe I'm guessing like it can handle a large amount of data.
I think for high accuracy.
Correct. See, everybody is connected with the internet. All the single businesses, whether public sector, private sector, they are onboarding itself on the online mode. It means the volume of data is very, very large. And deep learning can able to handle such a large amount of data. Therefore, deep learning is very, very popular. The first point is the growth in the data, in the data size. Second, I believe hardware advancements. So right now, what happened? The cost of hardware becomes half and the performance becomes 2x. The technology, the kind of television, fridge, the cost you pay right now with the same cost 10 years back, you get the very minimal durable product. You might have realized the cost significantly goes very down and the performance definitely gone up. Would you agree, guys? If you talk about the storage devices, we have
Yes.
GB, TB, yottabyte, gigabyte. So again, we have developed great sophisticated software like hardware tools, which can also handle this large number of data and this higher computation processings. Okay, this is second important point. Third, because of Python and other open source libraries. So Python is contributing in the field of data science and AI is more than 15 years ago. So contribution given by Python and other open source library is tremendous. Now there are a lot of AI models available on the internet, which companies have released free of cost. You can test them, you can use them, you can get your work done. You don't have to pay anything. So all the end companies, Google, Meta, IBM, they all did the same. Now, next, cloud and AI boom. So if you want to develop a product, you don't have to develop a full-fledged servers at your home. You can rent all the resources on the online mode. Okay. And again, now we are living on an AI boom where every businesses and company wants to do artificial intelligence. So these are some use cases or reasons why deep learning is very popular. Those who have joined late, let me tell you, we are learning deep learning processes now. Okay. Few other theory point, let's differentiate between machine learning and deep learning processes. Okay, so in machine learning, we create machine learning models. In deep learning, we create the neural networks which have neurons, okay, which is inspired by the structure of the human brain. Works well with small to medium sized data. When your data size is small or medium, machine learning is fine. It needs large amount of data to perform well.
So what's the cutoff, Govind, when you say small, medium, large?
There is no cutoff. As soon as we realize the performance of machine learning is not at all increasing, it's becoming stagnant, means it is reaches to the threshold point now. There is no fixed limit. Okay.
There is no fixed limit. Okay.
So here, if you talk about the feature engineering part, means which is the column, which column is most important for the output column, what are the best input column we have to select. So here feature engineering part is something you have to perform manually. So it requires manual feature selection. Here you just pass your data, automatically figure it out which column is more important for the output column. Okay, so here we can write automatic learns features from raw data. Now, fourth point is about training time. When you train something, training time in machine learning is a bit faster because the size of data is not that great. So here, training time is fast. Now, if we talk about the deep learning processes, it take a long time due to complex model and the size of data. Here the models are also a bit complex. Next, what we can write. See, if you talk about your machine learning made a prediction, you will say, Govind, how this model is working. It's easy for me to explain the internal working, but in deep learning process, it's more like a black box. Okay, so it's very hard for me or for anybody to explain how this neural network made a prediction for you. Okay, so this is the most common challenge you will face in every deep learning model, is that explainability part is missing. It will be very hard for you to explain the working of your model. Okay, so that is also one challenge. So easier to, in machine learning, it is easy to explain the working, because in deep learning sometimes it's automatically made the decision because it's more smart enough, and we will not able to realize how it has taken the decision. So here explainability is missing. It's more like a black box. The last point you can write. Here we have algorithms. For example, linear regression. We have decision tree, etc. And here we have the algorithms. ANN, CNN, RNN, LSTM, NLP, etc. etc. Okay, I believe, guys, these 6 points made you very clear difference between machine learning and deep learning process. Clear, all of you?
Yes.
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 Perfect. Now let's learn about some more disadvantages about deep learning processes, because nothing is best. It's not black or white. It's a black and white. Every concept in
Teacher,
machine learning
teacher, I
and
have
deep
one
learning.
question.
Hmm.
Did we cover reinforcement learning?
So it will be covered in your deep learning processes because some maths are there, okay, which will be
Okay.
covered along with that. Okay,
Thank you.
it will be covered. Now, guys, we have some disadvantages. The first one is it requires large data. This is one such challenge. Okay, because deep learning performs very poor on the small data because they overfit easily. High computational cost. To store such a big amount of data and to process the data, you need hardwares, which requires a cost. Means it requires powerful graphic card like GPU, TPUs, okay, which can be very expensive. Third problem, long training time. Especially with the large data set and very complex model because they have neural networks. It has a lot of artificial neuron. And let's say you have 1000 neurons, every single neuron will predict the output by its internal working. So definitely it becomes very complex and takes long time. Fourth point, less interpretability, as I explained already. Less interpretability. Now, fifth point means explainability is a bit missing. Needs for lots of labeled data. Labeled data means the data which have the output. So for supervised tasks, you need large amount of labeled data, which often very costly and time consuming. Yes, guys. So all this sort of supervised data, it's a bit challenge in the market. Okay, to assign a proper label to each data. Deep learning works well when you have enough amount of labeled data. Next, not always better than traditional model.
Teacher, can you give the example of label data?
Supervised data, a person is email is spam or not spam. You have the input column and you have an output column, which have input and output both. That output is called as label. Okay, so it's not always like it's better than your traditional machine learning model because of its complexity. When you have a small data, to better to apply machine learning models rather dealing with deep learning processes. And I would say, etc. So these are some traditional challenges you will face in deep learning processes. Now, guys, we'll discuss few terminologies now. What is neuron? What is neural networks? These things. What is artificial neuron? Anyone can explain what is neuron?
It's a
Brain cell.
brain that can respond to stimulus from the environment.
Correct. See, in biology, we have biological neurons, correct? But in deep learning processes, we have artificial neuron. Biological neuron is the basic building block, correct, of your structure of the human cells or something. So
Basic
here,
units.
yes. basic unit. Here is also a basic building block of your entire neural network. So we can quickly define it. And guys, I'll suggest you whatever small topic you have learned already in your entire journey so far from last 2-3 months. Have a proper note of everything. Means the small keywords definition you should know. The moment I say what is machine learning, you should be ready with 2 lines of definition and 1 example. Similarly, what is neuron, what is artificial neuron, and you have seen hundreds of terminologies. Please be ready with all those things, because in the interviews you will not get the time to think always. If you are thinking and then giving answers, means you will be using lot of fillers and all. It will not be very attractive. Thinking is something where you have to use some logic. Something you got a new problem statement, you are thinking about it and then trying to give the answer. Then taking time and using fillers is fine. But what about these simple definitions? Okay, just start doing it from now. Otherwise, during time of mock interviews and all, this thing would be stated to you. Advance, you can prepare it. Okay, because in the first round of interview, they will be asking these simple questions to you only in the screening round. If you fail, then again you have to prepare for next 1 month. Then only you will be eligible. Okay, so be ready with it. Now, what is artificial neuron? An artificial neuron is the basic building block of a neural network. And it is inspired by how biological neurons works. Works in the human brain. Now, dear, if you talk about how the artificial neuron looks, structure of artificial neuron. It has input unit, weights unit, sum of the weights, and bias. See, here you will receive input. Let's say your input is x1, x2, x3. Okay, and you will be also receiving one bias as the input format. Now, in the first segment, you will have weighted sum. You will have what? Weighted sum. W1, x1, W2, x2, W3, x3 plus B. This is called as a weighted sum. In a neural network, you have hundreds of neurons. This is one neuron, okay? I'm telling you the structure of one neuron. Every neuron may or may not be fired. Fired means their output will be considered. If you have 1000 neurons, every neuron will produce their output. But maybe all neurons are not capable of enough of producing the output. So there is a threshold limit we will be setting. If the output of the neuron is crossing a certain threshold, then only their output will be considered. Otherwise, the output of the neuron will not be considered. So that will decide the activation function. Who will decide this? Activation function. So now here you have something called as activation function. You have different types of activation function. You have sigmoid, ReLU, leaky ReLU, tan hatch, etc., etc. Let me just take one example of sigmoid as the activation function. So you have seen the formula of sigmoid function in the logistic regression class. It looks something like this. 1 upon 1 plus e to the power minus y. This y will be used as the input here. Okay. So what activation function does? It will decide whether your output, whether neuron is capable of producing the output or their output will be considered or not. And then only it will produce the output. And what is the limit condition? If the output is more than 0.5 or equal to 0.5, then neuron will be fired, means their output will be considered. If Z is less than 0.5, neuron will be not fired. Okay. Once again, you have an input layer, weighted sum, and this is the activation function. W1, W2, W3 are called as weights. So what are weights?
Percentage.
So here x1, x2, x3 are called as weights. Data feed to neuron. Second, you have weights W1, W2. Means how much importance you are giving. It's more about coefficient, okay? How much importance given to each input. Weighted sum y equals to W1 x1 plus W2 x2 W3 x3 plus p. This is weighted sum. What is bias? It's more about trade-off, okay? A small constant okay, a kind of trade-off which will protect this equation of not becoming 0. And then finally you have activation function. It will decide whether a neuron will fire or not. Will be fired or not. Example, you have sigmoid function, a ReLU, Riki ReLU, etc. Okay, so I'm giving you guys this quick note because we are starting with our first model, that is artificial neural network. So I'm giving you this quick note. Please have a look at it. Just 1 minute.
Teacher, did you share?
I'm sharing. 1 minute. Let me just convert it. Okay. I'm converting in the PDF. I have given the notes in chat box. Just revise it from starting. And I added a few more text at the very end. Please read those text also at the end of the page.
I have a question.
Yes.
So when you define the artificial neuron and you show the structure, you say we have the input and the bias. The bias is represented by the B, right? If it's the same we
B.
saw before. Okay. So if deep learning automatically learn from the future from raw data, how it did it at the beginning when it just started, or it was
See,
coming
same
after
thing. See,
learning?
here is the same thing. Whatever you did in the machine learning, you start with the training process. You create a model, right? Here you will be
Yeah.
creating a neural network. It will be very new in the beginning. You will be training it and then testing it. Okay, same thing will be going train and test.
Mhm.
It will be seeing lot and lot of data. It will learn the pattern from the data. Using this pattern, it will predict the future output, and the pattern can be only learned when you train your model, right? The way you
Yeah.
did in the machine learning process. The process is same. The model is changing. The algorithm will change along with the algorithms. That's all. Everybody revised? Done?
Yeah.
Others, just confirm if you are all done.
Yes.
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 Okay, we did a lot of theory so far, but
Yep.
this theory is important. The first model is artificial neural network. So it stands for artificial neural network. This is the very first point. Second, it is a group of interconnected artificial neuron. Artificial neurons organized in layers and designed to learn pattern from data. Okay, it's a kind of neural network, okay, which have a large number of interconnected neurons. Okay, so if I talk about the structure, mainly you have two things, three things. It will have input layer, second, hidden layer. If you want to make your network more and more complicated and more powerful, you just keep on adding more number of hidden layers. Third, output layer. that gives the final prediction. So see here, if I show you the structure graphically, we have two types. Simple ANN and dense ANN. Means dense ANN means it will have more and more number of hidden layers. This is a simple ANN structure. It's not very clear. See, this is the structure of simple ANN. You have input layer, and in between you have one or two hidden layers, and then output layer. Now, when you talk about dense ANN, it is look something like this. Very simple. You will just increase the more and more number of hidden layers. The structure will same input, output, hidden layer, but the amount of hidden layer will decide your network is simple or dense. See, and these circles are, see, this is called as layer. You have multiple layers. In every layer, you have this block is called as node, and every node have the neurons. Got the idea how guys simple ANN and dense ANN looks?
Yes. Could a dense ANN cause overfitting?
Sometimes. So it's just that we have to be very sure how much hidden layer need to be added. If you add so many hidden layers, definitely it will run a lot of noise, which makes the model overfit. Okay. Now, guys, we will be using here one data set, that is MNIST handwritten digit data set. Remember, in the decision tree machine learning model, we have used load digit data set. Remember anybody? Load digit data set?
Yes, we use that.
Correct. And that time I told you, in this particular data, this is a subset of a larger data set. And the larger data set is called as MNIST. And we will be using the MNIST full-fledged data set in the deep learning classes. So now I'll explain you how this MNIST data structure looks. MNIST handwritten digit data set. So first of all, data type. You have three things. First, data type, then image size, channels, classes, training set, test set, and label. Listen, it's an image data set, which is grayscaled. It's an image data with grayscaled. Image size. Every image is 28 by 28. In load digit, what was the dimension of data set? Tell me. Image size
8
in
by
load
8.
digit.
8
8
by
by
8.
8. Very good. So you had 64 pixel. 28 multiply 28. How much?
784.
784. So in short, you will be having 784
74 pixels.
Means the size of image will be larger and the quality will also be better. Correct? Simple. Channel. Channel means it's a grayscale image or colorful image. So channel is 1. 1 means it's a grayscaled. Not RGB. RGB means colorful. Okay. Now classes. How many class you will have? 10 classes. Same thing from 0 to 10 or 9.
0 to 9.
0 to 9. Very good. Now total image is 70,000, from which 60,000 images are training image. Okay, 60,000 images are training image and 10,000 images are testing image. And label is nothing but input
Output.
integer.
Oh,
It's an input integer 0 to 9. This is how label means. Label means output
okay.
data.
Output data. Yeah.
This is how it looks. So I'm giving you a quick description of this. One moment. Guys, I have given one link in the chat box. Please review this, everyone. And again, here the pixel value will be from 0 to 255. In your load digit, you have pixel from 0 to 16. But in MNIST, you will be having pixel from 0 to 255. 0 means pure black, 255 means white. Guys, revised everybody? Done with the revision? Okay, now we're gonna see the practical implementation of ANN, like how to develop this model. You can have a quick break. Okay, then we'll be learning about it, the practical part. Okay, back everyone.
Yes, I'm back.
Okay, perfect. Kindly open a Google Colab because we are going to perform one quick hands-on on artificial neural network.
Done.
And we are going to use MNIST handwritten digit dataset to work on this. First of all, guys, you have to use the import required libraries. Importing the libraries. Let's say import numpy. And here we will be using TensorFlow library. Mainly you use sklearn library in machine learning models, but for deep learning implementations, we will be using TensorFlow library. TensorFlow library is basically owned by Google. And what is TensorFlow and Keras? So TensorFlow is the big library and Keras is the simplified version of TensorFlow. Because when TensorFlow was launched in the starting years of around 2000, then developer searchers faced a lot of issues in understanding the TensorFlow structure and very difficult to work with it. Therefore, they come up with the idea of Keras, which is a wrapper around your TensorFlow library. Okay, so we will be importing Keras also. So we will be writing from TensorFlow import Keras. Now, this is loading. Let me just complete this hands-on. Once I done this, I will be giving you the file you can complete in your machine. Importing.
We don't need the warnings in here.
You can have that. List you the warning also. So this is the structure here. You will use training data first and then testing data. X train comma Y train. This is the training data and X test comma Y test. This is the testing data. This is how you will be loading. And then you type keras dot datasets dot mnist dot load data. So this is loaded up. is downloaded. If I just show the shape, how many training data we have? If I just say length of X train, how many? 60,000, right? And if I say length of X test, what is the answer? 10,000. Why? Totally 70,000. Training is 60,000. These are images. Okay. So we have total 70,000 images. Now, if I just let's take the first image. So you say X train and 0. This is the data. This is how the data looks. It is 28 by 28. This is how data actually looks. What is the maximum pixel value here? Tell me. Maximum pixel value. Tell me guys the maximum pixel value here.
28 by 28.
No, 256.
784.
255, sorry, 255 is the maximum pixel value. And 0 is the minimum. 0 means black.
Oh my God.
55 means white. Okay?
Mhm.
See, 255 is the maximum value. Understood? Pixel value, guys?
Yeah.
Mhm.
That's a grayscale image. Now, you can check the shape here. Shape is X train. You have 60,000 images. And each image is 28 by 28. I'm taking the entire input training data. The shape is 28 by 28 for every image. And how many image we have? 60,000. This is how you will be reading it. Let's take some image apart. Let's plot it. Plotting the image. plt.im show xtrain 0. Tell me what is this figure looks.
5.
And since we need to convert it to grayscale, so C map equals to gray. To verify this is the correct or not, the first output should also be 5. Y train
Yeah,
at 0.
right.
What it says?
5.
5,
Five.
correct? Yeah, so it's verified. One more, let's take plt.im show xtrain 500. What is this?
2.
2. And it's more clearer than the MNIST one, like the handwritten digit that we have used for low digit data, correct? Because here pixel
Mhm.
size is extremely great. 28 by 28, and that was 8 by 8. Here if you verify, Y train 500. See 3. Okay, it says 3.
Yeah.
Oh, how come?
It's 3, half 3.
Yeah, I was going to
it's-
say 3, but it wasn't complete.
Yeah,
Yeah.
it was incomplete.
Is that a 499 we should be giving? Anyway, it's the same. Yeah.
Sorry, come again?
No, I think it should be good. I thought it's
Okay.
499, but that's fine.
No. See guys, in deep learning process, we have to apply the scaling, because if you look at the pixel values, some pixel value is 0, some pixel value is 255. You have a huge gap. Agree?
Mhm. Yes.
Now, standard scaling is not just one approach. Scaling means you are trying to reduce the difference, and difference can be reduced in either of the way. For example, I will be using here different approach so that you think like it's not fixed. What is the minimum pixel value? 0. Maximum 255.
55.
Now I will divide the entire pixel. So I will divide every pixel value by 255. If you divide 0 by any number, it will remain 0.
0,
And this becomes
1,
1,
so your minimum number become 0. Maximum
0,
becomes 1.
1.
And rest of the value between 0 to 1. Right?
Mhm.
Because rest of the value between 0 to 55, correct? It was the
Yes.
minimum value, it was maximum value. And now after conversion, it becomes 0, it becomes 1. This is also scaling, correct? The difference got reduced. Agree, guys?
Yes, that's
Yes.
correct.
Perfect. So we are going for normalization, or you can say feature scaling. So you will take xtrain, and we only do it for input data, not for output. You will take your xtrain, divide by 255, and take xtest, divide by 255. Now if I show you 0 value, it looks like this. Converted? Initially it was like this. Now it becomes like this. Clear?
Uh-huh.
yes,
Now one
Yes.
more thing, guys. Now if I just show you here xtrain dot shape, it says what? 60,000 comma 28 by 28. This is 3D. We need to convert into 2 dimension. See, 28 by 28 is the pixel. So it means how many pixel you have? 784.
784.
And then this is nothing but your input column. Yes or no? So you have
Yes.
to convert the shape into like this. 60,000 images, comma 784. This is the form you have to convert. Same thing for testing. In this form only the input and output will be accepted. So now this is called a flattening the data. So xtrain becomes xtrain dot reshape, correct? And we will be giving 60,000 comma 784. Same for xtest. Xtest dot reshape. Reshape, what is the next point? Number of points should be same. Then you can convert from any dimension to any other dimension. For testing, you have 10,784. And now check. Got it? Everybody?
Mm-hmm.
Yeah, it is changed. Now, first of all, I will be creating a simple ANN, then I will be creating a dense ANN. So heading is simple ANN. It will just have an input layer and output layer, okay? And the input layer works as a hidden layer. See, I'm giving here a simple ANN, okay? Keras, we will create with the help of Keras, sequential. First time you are doing it, don't worry, you will eventually learn. This is the idea of writing structure. Sequential, Keras dot sequential. Then we define the layers, how many layers we need. We want just one layer. The same layer works as an input layer, output layer, and hidden layer. Very, very simple ANN I wanted to create. Okay, later I will add more and more layers. So Keras dot layers, dense. I will pass 10 neurons. Why? Because it will also act as my input data, output data. So how many output classes you have? 10 class. Therefore, I pass 10 neurons. Input shape 784. Because how many pixels you have in every image? 784. This will act as the input. And I told you everywhere you will pass the activation function that will decide whether neuron will fire or not. I passed 10 neurons. Which activation function I will pass? Sigmoid. As of now, I'll pass sigmoid. We will be taking a dedicated class on sigmoid activation function. You will be learning about other types of activation functions also. Then you compile the model. You will take simple ANN dot compile. Compile means what matrix you want to see when the result will be displayed. So I will be using here as an optimizer. What is optimizer? It will decide the best value of base like bias and your weight. So I'm using here Adam. You have so many, but I'm using Adam here. Loss, what kind of loss you want to see? Sparse, categorical, cross entropy. I will take one more class on loss function also. What kind of loss functions you can use in deep learning models. And matrix, I will be using accuracy. Then we will use fit. Simple ANN dot fit. Fit on which data? Xtrain and Ytrain. And here we have something called as epochs. Epochs means number of cycle. See, in machine learning model, when you run it, it only train once. But when you pass epoch as 5, so your deep learning model will train how many times? 5 times.
Five
It's just the
times.
number of cycle you want to go for the training process. And every training process will have a result of loss and accuracy. Then you can compare. Is this increasing when we are retraining the model or not? Means it is for better learning. This is for first epoch. In the first epoch, see the accuracy is coming out to be 82% and loss is 69. See in the second epoch, accuracy increased, yes or no?
Yes.
Yes.
So eventually we see our accuracy is increased from 82% to 92% and
92.
loss have decreased, correct?
Mm-hmm.
Now you can say, Govind, we need to pass more and more epoch. No, we have to be a bit logical. Every time we cannot afford to pass so many epochs because when your data size is very, very large, every iteration comes with a hardware cost, right? So it's just that when you are seeing a significant growth, then we keep on increasing the epoch. Otherwise, we give a fixed number. But at
Teacher,
least
epochs means cycle.
a number of cycle your model will be running in the training
And can you
process.
explain sigmoid again?
A kind of activation function which will decide which neuron will fire. So the threshold for sigmoid function is 0.5. If the neuron value, the output of neuron is 0.5 or more than that, only those neuron will be considered, otherwise other will be discarded. Okay. One such type of activation function. Epoch
Activation
means
function.
number of cycle the model will be running in training process. Now, once you are done with this, then you can also evaluate the testing accuracy. So you will write simple ANN dot evaluate. Okay. So you pass X test, comma Y test. This will give the testing accuracy. So testing accuracy is 92% and loss is this around 26. So I
Can we
think
use epochs here?
no. In the training
No?
process only we use the epoch. This is for testing data
Gotcha.
you have. Okay, on the same model we are evaluating the score just. Okay.
Okay.
Now guys, it's
Okay.
time for prediction. See, prediction part is most important. You will get confused also here. So main part. So be alert this time. See, why pred 1? Because I will be using dense model also. There I will pass y pred 2. So I'm going to test. So y pred 1 is nothing but I will write simple ANN dot predict. You will say, Govind, most of the functions are common from the machine learning. Agree? Process
Yes.
is same. We pass testing data. Now let's see the first output, first predicted output. This is the answer. How many test data you have? Quick answer. How many test data you
313.
have?
313.
Oh,
10,000.
10,000.
10,000. Yeah.
See, this is the batch size. This is the batch size. So see,
Okay.
1875 out of 1875, you have 60,000 images. So those images got divided into 1875 batches. Okay, so it is running batch wise. Got it?
Got you.
So see, if I check the first answer, it should be give me the answer like 1, 2, 3, 4, 5, 6, 7, 8, 9, any number out of this as the output data. But see, it's giving me the probability distributed value. What it means? So in deep learning, it never predict the direct answer. It provides the probability for all the outcome. How many classes you have? Tell me. 10 classes?
10.
Yes.
So for every class, it will make a prediction. This is the
Mm.
possibility for that class. This is the possibility for this class. So which number is highest here? It will be hard to tell you. Why? Because it is exponential number. See, last May you have e to the power minus 2 something like. See, correct?
Mm. Mm.
So you have one functionality. So I have to convert this into, I need to find the highest number because that is my prediction. The index have the highest value. That is my answer. Simple. So here, higher the probability will be my answer. To achieve this, we will be using to achieve this, we will use np.arg function and list comprehension approach. Listen. So you will write np.arg max and you will pass the entire value from here to here. See the answer. What it says?
7.
Answer is 7,
7.
right?
7. Yeah.
Means 0, 1, 2, 3, 4, 5, 6, 7. This is my highest value. So the answer for first outcome is 7.
So the 7 is an index number?
Yes, and my output is also from 0 to 9. So it's matching, right?
Mm.
Index also begins from 0 and my output also begins from 0 only, correct? So the first answer which is predicted by my deep learning model is 7. But I have 10,000. I can't calculate one by one. Agree, guys?
Mm.
Yes.
So we need to apply a simple for loop which will compute the result for all 10,000 value and give me the discrete answer. It's giving me the probability distributed answer. I need discrete label. So let's compute the discrete value, discrete label or discrete output for entire 10,000 data points. So ypred label 1. This is the final answer I will be storing in this. Ypred actually was storing the predicted output, predicted probability output. Here I will store the concrete output. Listen, so np.argmax. I will apply list comprehension. List comprehension is the combination of for loop and conditional statement. List comprehension is the combination of for loop and conditional statement, and the result of list comprehension is a list. How? For I, you can write, let me just create a condition here quickly. For I in Y, so first of all, I will one by one go into ypred 1 and take one value and convert into the label? Yes or no? My all answer is stored in ypred1, correct? So one by one I will fetch from ypred1 because this is containing the probability distributed value. So for I in ypred1, now when you take the value, you will pass to np.argmax your I, and then it will be storing the result in here. So now how to read this? Don't read from here, read from here. For I in ypred1 means my for loop will run one by one, it will fetch value from ypred1.
Ypred1.
And where to pass?
Here.
np.argmax, right? And now see, ypred label 1, I want to see first 10 values. See, this is the answer. It's converted for all 10,000 values. Agency is the first 10 record. Understood?
Yes.
Yes, I have a question. I didn't want to interrupt you before. So I don't know if you can scroll up a little bit. Here, when you put ypred 0, that's 313. What is?
This is just a batch number. See, for testing data, the batch size it has taken for 313, right? The batch size it is showing is not a very important information. You need to look from here. This
Okay,
much.
and can you go a little up again when you show the cycles, the epochs? So there, each cycle has better accuracy. So is, for example, the third cycle learning from the second, and second also learning from the first?
Yes, yes, yes.
Okay.
It's a feed forward network. Okay,
Mhm.
the feed forward network. So now, guys, we actually got the. So here it was a bit tricky. It's a two-step process to compute the predicted output, right? Now, this is a classification task. You have 10 output. Can we compute the Can we compute the confusion matrix? Tell me. It's possible here to compute the confusion matrix. Tell me. It's for regression or classification?
No, it's a
Yeah.
confusion is for
Classification.
classification.
Very
Yeah.
good.
Yeah.
Let's compute it. So TensorFlow dot math dot confusion matrix. Labels I will pass as y test actual output, and in predictions I will pass ypred1 underscore label. Okay, ypred label 1. You pass actual output and predicted. This is your actual output. This is your predicted output. Now I'll say CM. You got the confusion matrix. And this is your correctly classified value. Correct, guys?
Yes.
It's 10
Yes.
cross 10. Why? Because you have 10 output. Okay,
10
let's
class.
convert into a quick heat map for better interpretability. So converting the confusion. So if someone says, is machine learning linked with the deep learning, or machine learning is the prerequisite? Would you agree?
Yeah.
Is machine learning is the prerequisite for deep learning? Agree, all of you?
Yeah.
Yes.
Yes.
Now we will decide a figure size, plt dot figure. I have seen so many learners who say, well, in my company, we have a requirement for just deep learning only. I just wanted to learn deep learning process. I get a lot of consultancy also. Only deep learning, the corporate want to train their employee. It's not possible. I tried also multiple times, but I failed to explain the concept. they eventually become confused.
Mm.
FMTD means actually, if you don't write it, let me just plot it without writing this. PLT dot X label, actual output. Sorry, in X we have predicted output. Okay, EL. See the answer. It is giving in the exponential format. See the diagonal, guys, correct? To
Yes.
convert the diagonal, which is in exponential format, into numerical format, you will be writing FMT, formatting. FMT stands for formatting. D stands for decimal, means integer. See, I'm able to convert my confusion matrix from raw structure to the heat map. Okay, so this is how it process. I'm giving this collab file link. Just do it in your machine. And let me know if you have any questions at any step. Just implement it. Your fear will go out. Guys, you all completed?
Teacher is still working.
Okay, I'm sharing the today's quiz also.
Teacher, can you share the link of quiz which you shared on 17 May?
No, that is not possible since the quiz got expired once we in the class.
Okay.
Okay, the date is set. I share the quiz in the chat box.
Is the truth working?
Okay, perfect. Thank you so much, guys. Please practice this, and we will be implementing the dense layer of network in the same hands-on in the next class. Okay, so take care. Bye bye.
Thank
Bye
you.
bye. Have a
Thank
good
you.
one.
Bye-bye.
Thank you.
Thank you.